summary of the parallel and series connection, the information that we found. This is a parallel combination for two capacitors. You put the left plate connected to the left plate, the right plate connected to the right plate, and then they both connected to the battery, and this side connected to the battery. The potential difference across this capacitor is exactly the same as the potential difference across this capacitor, is exactly the same potential difference of the battery. And if you want to make one capacitor that does the same job as these two, same job meaning that it supplies the same amount of charge on each side, which in this case is Q1 plus Q2, then this equivalent capacitance will have a value C1 plus C2. And this is what the equivalent circuit would be. The charge would be plus Q and minus Q, and C equivalent under the same potential difference. For a series connection, you connect the right plate of this capacitor to the left plate of this capacitor, and nothing else should be connected between these two plates, no other wires, no other capacitors or anything. And when you do this connection this way, the potential difference across this capacitor plus the potential difference across this capacitor is equal to the potential difference across the battery. And if you want to make an equivalent capacitor that does the same job as this battery, in this case it supplies an amount of charge plus Q on one side. So this battery also supplies an amount of charge plus Q on one side. And the equivalent capacitance in this case will be obtained by this formula. 1 over C1 plus 1 over C2 is equal to 1 over C equivalent. So this is a capacitors in series. And remember, capacitors in series, the charge here, if it's plus Q, this is minus Q. This is plus Q, this is minus Q. They're all the same magnitude, but just the sign is different. This is very important in solving problems.